Most green hydrogen projects die long before construction. They win headlines, secure MOUs, announce gigawatts of ambition, and then quietly disappear somewhere between concept studies and final investment decision. That is the hidden reality of the hydrogen economy right now. The world is flooded with announcements, but starved of projects that actually survive bankability, permitting, offtake negotiations, financing stress tests, infrastructure constraints, and real industrial demand. And that is exactly why the Barrow Green Hydrogen project in the United Kingdom matters far more than its 30 megawatt size suggests. This week, the Barrow Green Hydrogen project officially reached final investment decision, with Plug Power supplying the PM electrolyzers for the facility. The project is being developed by Green Hydrogen Energy Company, a joint venture between Schroders Greencoat and Carlton Power. At first glance, a 30 megawatts electrolyzer project may not sound civilization-changing. But in the current hydrogen market, this is not just another hydrogen project. This is something much more important. This is proof that parts of the green hydrogen market are finally beginning to escape the pilot phase trap. And that changes the entire conversation around hydrogen. Because for years, the hydrogen industry has been operating in two separate realities. One reality exists in PowerPoint presentations, government speeches, and trillion-dollar future projections. The other reality exists in engineering offices, financing committees, and industrial procurement meetings, where executives ask one brutal question: will this actually make money? That second reality is where most hydrogen projects collapse. And the collapse is happening globally. Over the past year, the green hydrogen sector has been hit by cancellations, delays, downsizing, and capital freezes across Europe, Australia, and North America. Major developers have scaled back ambitions as costs remain stubbornly high, and industrial demand failed to materialize at the speed many expected. Even some of the biggest names in energy have slowed projects. Steelmakers delayed hydrogen conversion plans. Utilities reduced electrolyzer ambitions. Oil majors postponed infrastructure decisions. The industry discovered something uncomfortable, building green hydrogen is not the same thing as building a viable hydrogen economy. And that distinction matters enormously. Because electrolyzers are not the bottleneck anymore. The real bottlenecks are utilization rates, renewable power pricing, long-term offtake agreements, transmission access, permitting timelines, water systems, compression infrastructure, financing costs, policy certainty, and industrial willingness to pay a premium for low-carbon molecules. That is why reaching FID is so important. FID means the project has crossed the threshold where investors, lenders, contractors, insurers, and industrial customers collectively decided the economics and risks were acceptable enough to move forward. That is a completely different level from a press release. And the Barrow project crossed that line. The facility will use 30 megawatts of Plug Power Geneco PEM electrolyzers powered by renewable electricity to produce green hydrogen for industrial decarbonization in northwest England. But the hidden story is not the electrolyzer. The hidden story is the system around it. Because this project reveals what the next phase of hydrogen development actually looks like. For years, the hydrogen industry sold a fantasy that massive global hydrogen demand would appear automatically once electrolyzers became cheaper. But the market learned something much harsher. Cheap electrolyzers alone do not create bankable projects. Hydrogen is not a smartphone app. Hydrogen is infrastructure. And infrastructure only survives when entire systems align simultaneously. That means power supply, industrial demand, transport logistics, financing, regulation, and policy support all have to move together. The Barrow project appears to have achieved exactly that alignment. One of the biggest reasons is industrial offtake certainty. According to reports tied to the project, Kimberly-Clark has secured hydrogen offtake from the facility for nearby manufacturing operations. That single detail may actually be more important than the electrolyzer technology itself. Because hydrogen projects fail when there is no guaranteed buyer. The hydrogen market learned this lesson painfully over the last several years. Many projects assumed future demand would emerge naturally. Instead, industries hesitated because green hydrogen remained more expensive than fossil-based hydrogen. That created a deadly loop. Developers needed demand before financing projects. Industrial buyers needed low prices before signing contracts. And without long-term contracts, banks refused to fund infrastructure. The Barrow project appears to have broken that cycle. And that makes it a signal event. This is the transition from speculative hydrogen to contracted hydrogen. That transition is everything. Because once hydrogen projects become anchored to real industrial demand, rather than theoretical future markets, the economics start behaving differently. Investors gain confidence, suppliers gain confidence, governments gain confidence, and neighboring industries begin exploring integration opportunities. That is how industrial clusters form. And the UK has been trying aggressively to create exactly those regional hydrogen ecosystems. The Barrow project is also supported under the UK government's Hydrogen Allocation Round 1 program, commonly known as HAR1. That policy support matters enormously because green hydrogen remains economically fragile. This is one of the most misunderstood realities in the entire clean energy industry. Many people assume hydrogen simply needs more scale to become competitive, but the actual economics are far more complicated. Green hydrogen sits at the intersection of electricity markets, infrastructure finance, industrial commodity pricing, and utilization risk. And utilization risk may be the single most important variable of all. An electrolyzer that operates at high utilization spreads capital costs over more hydrogen production. An electrolyzer with poor utilization becomes catastrophically expensive. That means renewable power availability is not just important, it is existential. If electricity prices spike, hydrogen costs spike. If renewable intermittency reduces operating hours, hydrogen costs surge. If grid congestion delays power delivery, economics deteriorate rapidly. This is why geography matters so much in hydrogen. And it is why some hydrogen projects in theory-rich regions never become financially viable in reality. Hydrogen is brutally unforgiving to poor system integration. That is also why many hydrogen projects worldwide remain stuck in the announcement economy. Only a small fraction of announced global hydrogen capacity has historically reached actual implementation timelines. That implementation gap is now becoming one of the defining stories of the global energy transition. And that is where Plug Power enters the picture. Because Plug Power's story itself reflects the broader tension inside the hydrogen economy. The company became one of the most recognizable hydrogen brands in the world during the hydrogen boom years. But it also became a symbol of the sector's volatility, capital intensity, and financial pressure. Plug expanded aggressively into electrolyzers, hydrogen production, logistics fuel cells, infrastructure, and mobility systems. But the market eventually forced a difficult question onto the entire sector. Can hydrogen companies survive before the hydrogen economy fully exists? That question has crushed many firms. And Plug itself has gone through periods of financial pressure, restructuring, project delays, and liquidity concerns. Which makes this Barrow FID even more important strategically. Because this is not just about selling electrolyzers anymore, this is about proving that real industrial projects are still moving forward despite the hydrogen sector's turbulence. And investors are watching this very closely. Not because 30 megawatts changes global hydrogen supply overnight, but because it suggests that a new hydrogen development model may finally be emerging. Smaller, cluster-based, industrial-first, offtake secured, policy-supported, infrastructure integrated. That is a radically different model from the old gigawatt announcement era. And honestly, it may be far more durable. Because the hydrogen industry is slowly learning that scale alone does not guarantee survivability. System integration does. This is where the broader industrial decarbonization story becomes fascinating. For decades, heavy industry optimized almost entirely around cheap fossil fuels. Steel plants, chemical facilities, fertilizer systems, refineries, ports, shipping networks, and manufacturing zones were designed around hydrocarbons that were dense, transportable, and continuously available. Hydrogen changes that equation, not just technically, systemically. Because hydrogen forces industries to reconnect with electricity infrastructure in ways they have not experienced for generations. Now power markets suddenly influence chemical manufacturing. Grid congestion influences fuel production. Renewable intermittency influences industrial scheduling. Transmission bottlenecks influence hydrogen pricing. This creates an entirely new industrial geography. And projects like Barrow may represent early examples of how future industrial clusters reorganize themselves around low-carbon molecules. That future is not guaranteed. In fact, there are still enormous risks. Green hydrogen remains expensive relative to conventional hydrogen. Electrolyzer supply chains still face scaling challenges. Power pricing volatility remains a major threat. Water availability becomes increasingly important in some regions, and policy dependency remains dangerously high across much of the sector. That uncertainty matters because hydrogen infrastructure requires massive upfront capital commitments with long payback periods. And capital hates uncertainty. Which brings us to the deepest lesson hidden inside the Barrow project. The future hydrogen economy may not be won by the biggest announcements. It may be won by the projects that survive reality. That is a completely different competition. Because surviving reality means surviving engineering constraints, financing scrutiny, policy shifts, infrastructure bottlenecks, industrial skepticism, utilization stress, and commodity price volatility simultaneously. That is not a technology challenge anymore. That is a systems challenge. And systems are much harder than prototypes. This is why the hydrogen industry is now entering its most important phase yet. The hype phase is ending. The execution phase is beginning. And execution is where the real winners emerge. Not the companies with the biggest renderings, not the companies with the most aggressive forecasts, but the companies capable of building integrated systems that industries are actually willing to pay for. That is the hidden significance of Barrow. It is not proof that hydrogen has already won. It is proof that parts of the industry may finally be learning how to survive. And that distinction could define the next decade of industrial decarbonization. Because the future hydrogen economy will not be built by headlines alone. It will be built by projects that make it through the brutal filter called reality.